Today we are going to start class 11 chemistry chapter number 9 acid base chemistry and pH. Today our topic discussion is ionic product of water. First of all we see pure water is a poor conductor of electricity but its conductance is measurable. Next we see why pure water does not allow electric current to pass through. It is because it has very few charged particles. Next, we define an important term like conductance. Conductance means the ability of a substance to conduct electricity. If conductance is low, it means very few ions are present. But even though water is a poor conductor, it still shows a small but measurable conductance, which proves some ions are present. Next, we see water undergoes self-ionization reversibly. This means that water molecules react with each other and break into ions on their own without any acid or base added. Now we define two important terms like self-ionization and a reversible reaction. First we define what is self-ionization. Self-ionization is a process in which a substance like water splits into ions by itself without using any other chemicals. Now we define what is reversible reaction. Reversible reaction is one where the forward and the backward reactions happen at the same time. It is shown by the double arrow. Next we understand this concept to a chemical reaction. As we can see this reaction, in this reaction one water molecule donates an hydrogen ion, a proton to another water molecule. The one that gains the hydrogen becomes hydronium ion and the one that loses hydrogen ion becomes hydroxyl ion. Sometimes we write a simplified form as we can see this chemical equation. This means one molecule of water breaks down into one hydrogen ion and one hydroxyl ion. These ions are responsible for the small electrical conductance of water. Now we write the equilibrium constant expression for this reaction. Now we see what is equilibrium constant. The equilibrium constant, written as Kc, is a number that expresses the ratio of the concentration of products to the concentration of reactants at equilibrium. In this case, hydrogen in brackets means the concentration of hydrogen ions and hydroxyl ion in brackets means the concentration of hydroxide ions, and water in bracket means the concentration of water molecule. Next we see how to calculate the concentration of water in pure form and how it relates to the ionic product of water. First of all we see what is concentration. Concentration means how much of a substance is present in a certain volume. It is usually measured in mole per decimeter cube, which means moles per cubic decimeter. Now we see concentration formula. The basic formula for concentration is equal to amount of substance in moles divided by volume of solution in decimeter cube, or simply C is equal to N divided by V. Here C is concentration and N is equal to number of moles. V is volume in decimeter cube. Next we see how to find the concentration of pure water. As we know, mass of water is equal to 1000 gram per decimeter cube. Molar mass of water is equal to 18 gram per mole. So by putting these values in this formula, we get N is equal to 55.5 moles. Now C is equal to 55.5 mole per decimeter cube. Now we see what is Kw. Kw is the ionic product of water. It tells us how much hydrogen and hydroxyl ions are present in water due to ionization. Here Kw is equal to ionization of hydrogen ions and ionization of hydroxyl ion. Now we see that water does not ionize completely. Only a very small number of molecules break into ions like hydrogen and hydroxyl ion. Because of this, the concentration of water stays almost constant. To handle this in calculation, scientists multiply the equilibrium constant Kc with the constant concentration of water to get a new constant called Kw. Here Kw is equal to equilibrium constant Kc multiply concentration of water. Here we are given value of Kc, which is equilibrium constant water, and its value is equal to 1.8 multiply 10 to the power minus 16 mole per decimeter cube. The concentration of water is equal to 55.5 mole per decimeter cube. Now, by putting these values in this formula, we get the value of Kw, which is equal to 1.01 multiply 10 to the power minus 14. Next, we see the effect of temperature on Kw. Here we can see from this table, the value of Kw increases by increasing the temperature. As temperature increases from 0 degree centigrade to 100 degree centigrade, the value of Kw increases almost 75 times. Now we see the conditions for neutral water. In pure neutral water, the concentration of hydrogen ions is equal to the concentration of hydroxyl ion. Then we write the ionic product of water. Here we can see this equation. This is called ionic product of water and is represented by Kw. Since the concentration of hydrogen ion is equal to the concentration of hydroxide ion, we can write it as hydrogen squared is equal to the 10 to the power minus 14. Now to find the value of just hydrogen ion concentration, we take the square root of 10 to the power minus 14. The square root of 10 to the power minus 14 is equal to 10 to the power minus 7. So we get the concentration of hydrogen ions is 10 to the power minus 7 moles per cubic decimeter. Since the concentration of hydrogen ion is equal to the concentration of hydroxide ion, so the concentration of hydroxide ion will also be 10 to the power minus 7 moles per cubic decimeter. Now we see acid-base chemistry. When we add acid in water, the concentration of hydroxide ion decreases and the concentration of hydrogen ion increases. But if we add base in water, the concentration of hydroxide ion increases and the concentration of hydrogen ion decreases. But the value of Kw remains almost constant at 25 degrees centigrade